Alrighty, let's cover the last part, part B. Now, in this case, this is the 3D part that we need you to visualize. So, let's read the question first. RT is a vertical flagpole at R such that RT is 8.4 meters. So, the length of this whole thing is 8.4 meters. Calculate the greatest angle of elevation of T from the path PQ. Now, so, let me just erase all this. Now RT is standing upright, okay, is a flagpole standing upright on the ground. So you imagine if you place your pen on your paper vertically, right, that is RT, okay, it's standing upright on a flat surface. And they want you to find the greatest angle of elevation of T as seen from the path PQ. That means, right, there's some guy walking along PQ. Okay, there's some guy walking along PQ, and every time he looks at T, there's going to be an angle of elevation, right? Every time he looks at T. Okay, but they want you to find the greatest angle of elevation. Now, the greatest angle of elevation will occur when your distance from the flagpole is the shortest. Okay, why? Imagine if you're standing close to the flagpole, right? When you're standing very close to the flagpole, your eye will have to go up all the way in order for you to look at the top of the flagpole. But if you're standing further and further away from the flagpole, you don't need to like move your eye all the way up, right? You just have to move a bit and you can see the top of the flagpole already. So the shortest distance from the flagpole will give you the greatest angle of elevation, which means I have to use information from part 4 because I already found the shortest distance over here. Okay, so let me erase all this. I already know that if I were to walk along PQ, right, my shortest distance from the flagpole is over here. So if I stand here and I look at the top of the flagpole over here, that will be my greatest angle of elevation. I'm going to draw the line of sight over here. Now, can you see that this RT, okay, let's call this point G. Can you see that this GRT is actually a right angle triangle? Because this RT makes a right angle with surface, right? So this is a right angle triangle which is standing upright, GRT. Okay, I only know this side is 8.4. I know my length over here because I found out just now, right? Just now I found out it was 3.0896. Okay, and I'm supposed to find the greatest angle of elevation, which is over here. Recall that angle of elevation is the angle between the horizontal and the line of sight. So everything is now like upright, okay, is standing on the paper or on the flat ground. So if I want to find this angle and I have the opposite side and I have the adjacent side over here, which is the 3.0896, right? I can use my torcaso to find the angle over here. So before that, let me just find some space and, okay, let me just do it here. I'm going to redraw this triangle such that, you know, it makes more sense to me. Okay, I'm going to call this G, call this is already R, this is T. RT is 8.4. This is right angle, right? GR, just now we found, is the shortest length. It is 3.0896. And I'm supposed to find the angle TGR. Okay, so let me just define G for you because I haven't defined G yet, right? So let me define G. Let G be a point on PQ such that PQ is perpendicular to RG, right? RG is here and PQ is here, and they are both perpendicular. Okay, so just now, actually RG is the shortest distance, which is 3.0896. So now I can go and do my finding of this greatest angle of elevation. Because this is a right angle triangle, I'm going to use tangent. So tangent angle TGR is equal to opposite over adjacent, 3.0896, and I'm going to find angle TGR to be tangent inverse 8.4 over 3.0896. No space. Okay, press calculator. My angle will be 69.8 degrees to 1 dB. So just gonna write that 69.8 degrees. Bracket 1 dB. So this is the greatest angle of elevation. So write down somewhere in your notes, this is the concept that I need you to know. For part B, the greatest angle of elevation occurs at G. Okay, so basically just write down RG is the shortest distance. So this is the note for you to know that, okay, if I want greatest angle of elevation, means I need the shortest distance. Okay, with that we're done with this question. Now for homework, I want you to do the next two questions, which is example 13 and example 14, which I'll be going through tomorrow. Okay, the questions are quite long, so please really put in effort to try the questions. You must be very familiar with sine rule, cosine rule, area of triangle, Torcaso, Pythagoras theorem, half times base times height, angle of elevation, depression, and everything. Okay, visualizing 3D concepts, etc. Bearings as well. So example 13, there's actually a question on bearing. So please try that, and please try example 14 as well. I'll see you in tomorrow's video. Bye!